You know, it's something we do hundreds, maybe thousands of times a day without even thinking about it. But have you ever really wondered what's happening on the other side of that screen? What's the incredible journey of just a single click? Well, let's dive in and find out.
No, seriously, just stop and think about it for a second. You type up a message, you hit send, and boom, in a flash, it shows up on a screen that could be thousands of miles away. It totally feels like magic, right? But it's not. It's actually this brilliant, super high-speed delivery service. So what is going on in that tiny split second?
All right, so to really get our heads around this, let's use an analogy pretty much everyone can understand. Good old-fashioned snail mail. You're going to see that sending an email is surprisingly similar to mailing a letter. I mean, they both follow the same basic steps, right? You write something, you package it up, you put an address on it, and you send it off. And believe it or not, this simple comparison, it's the key to unlocking how the entire digital world works. Okay, so let's pull back the curtain on the magic behind that send button. It all kicks off with getting your data ready for its big trip. You see, the entire internet is basically built on an agreement, and this agreement comes in the form of what we call protocols. Think of it as a shared rulebook for how to communicate. It's like a universal language. It just doesn't matter if you've got an Apple computer or a PC, or if you're in Tokyo or Toronto. As long as every device follows the rules, it can talk to any other device on the planet. And here's where it starts to get really cool. Your email, that photo you're sending, it doesn't travel across the internet in one big chunk. Nope. That rulebook we just talked about, it says that your data has to be broken down into these tiny little pieces called packets. And there's a good reason for this. It makes the whole system way faster and a lot more reliable.
So how exactly does this rulebook get all those little packets ready for their trip? Well, it's all done in layers. And you guessed it, it's just like getting a letter ready to go in the mail.
Okay, let's walk through these steps. First up, you've got the application layer. Super simple. This is just you writing your email. Done. Next comes the transport layer. This is where a super important protocol called TCP, that stands for Transmission Control Protocol, jumps in. It takes your email and chops it up into all those little numbered packets we mentioned. And it's smart about it too. It adds a kind of digital checklist to each one to make sure nothing gets lost. After that, we have the network layer. This is where each and every one of those packets gets its digital address, kind of like the to and from on an envelope, but we call them IP addresses. And finally, the physical layer. This is where the packets transform into actual signals, like little zaps of electricity or flashes of light ready to travel. Now, this whole process of adding layer after layer has a fancy technical name. It's called encapsulation. And this is exactly why that postal service analogy works so well. Think about it. You put a letter in an envelope, which then goes into a mailbag, which then goes onto a truck. See? Each step wraps the original thing in a new layer with new instructions for the next part of the trip. It's a perfect system of nested instructions, getting your data all dressed up and ready to face the big, wide world of the internet. All right, so our packets are all packaged up, addressed, and ready to go. Now the real adventure begins, as they finally leave your device and start to navigate the massive, tangled web of the internet. So the very first stop on this journey is a little device called a switch. The easiest way to think of it is as the mail sorter inside your own house or office. You know, it's taking all the packets from your computer, your TV, your phone, and it makes sure they all get pointed towards the right exit door, which is your router, the gateway to the rest of the internet. And that brings us to the router, the great traffic director of the internet. And a router's job is, frankly, incredible. It grabs a packet, reads the address, and in a tiny fraction of a second, it consults this massive, constantly changing map of the entire internet to find the absolute best, fastest path. It's literally like a digital Waze for data, maybe sending one packet through London while sending the next one through Frankfurt, all just to avoid a digital traffic jam. And this journey is, it's truly epic. Your tiny packets, which are now just flashes of light, are literally zipping through thousands of miles of fiber optic cables laid on the bottom of the ocean. They're hopping between dozens of different networks across entire continents. And here's the most mind-blowing part. This whole globe-spanning trip takes less time than it takes for you to blink your eye. It's not just fast. For us humans, it's basically instantaneous. So the packets have made it, they've arrived at their destination. But right now, they're still just a jumble of coded signals. So now the whole process we just saw has to happen again, but this time in reverse, to actually bring your message back to life on the screen. The computer on the other end uses the exact same rulebook, but this time to unwrap the data. It starts at the bottom. The physical layer turns those flashes of light back into digital data. Then, the network layer takes a look, reads that digital envelope, and then just tosses it aside. Next up is the transport layer, where our friend TCP gets back to work. It pulls out its checklist, makes sure every single packet arrives safe and sound, and then arranges them all back in the correct order. And finally, the application layer presents the fully reassembled message to, say, the email program on the screen. And just like that, there it is, your original message, perfectly put back together, appearing on a screen thousands of miles from where you sent it. It's pretty amazing when you think about it. The system just works.
So when you zoom out from all the technical details, you start to realize that this is way more than just a clever delivery system. This is a fundamental principle, a kind of global agreement that allows our entire modern world to even exist.
So why does any of this matter to you? Well, because that shared rulebook, these protocols like TCP and IP, they created a universal language for machines. That's the only reason your iPhone can talk to a server that's running Windows without any problems. It's why a developer sitting in Tokyo can pull information from a database in Brazil. This simple agreement to follow the same set of rules is what makes the internet the truly global, open network that we all rely on.
And the sheer scale of this is, well, it's just staggering. We're talking about more than 100 trillion of these tiny packets making that journey across the internet every single day. That's 100 trillion little stories made of data, all following the exact same rules, all day, every day.
When you get right down to it, it's an incredible system that's built on trust and cooperation. But that same interconnectedness, that reliance on a shared rulebook, also makes the whole thing vulnerable. So it begs the question, if the entire internet is built on everyone agreeing to follow a shared rulebook, what happens when someone, or something, decides to break the rules?